Now we will go for one of the types. Let us start with the cheaper one. Say we decide we would like to use LED display. LED display. We would like to use LED display. And how many displays we can start with? How many digits? 4 digits is fine initially, right? So we put the specification in front of us that we require 4 digits. 4 digits, right? So what is the maximum frequency it will be able to show? 1. Can it not? It depends on the resolution. It can show 1 megahertz also, but the meaning of whatever is shown is based on what is the instrument, what is the multiplying factor, right? If the number shown is say 999, so it can be 999 hertz also, 999 kilohertz also. It depends on what is the multiplying factor. So digits will not tell us the range anyway, but digits give us idea about the range, but not the full information. Anyway, so we have 4 digit value. So 999 is the maximum number that we can display, right? Now we have to connect this display to the microcontroller. This is our microcontroller, and we need to connect 7 segment displays to the microcontroller somehow. Now to decide how it should be displayed, we need to understand what are the types of connections to the microcontroller. There are 2 kinds of connections to connect displays. One is the static connection, static display, and the other one is dynamic or multiplexed display. Multiplexed display. Static display and multiplex display, right? So we need to understand what is static and what is multiplexed quickly. Right. So static display means all digits are on. All digits are always showing data. Showing data, that is value. For example, if the data shown is say 3, 4, 2 and 5, then these many LEDs will be on all the time. How many LEDs are on at this time you can count, but these many LEDs will be on and they will all be consuming power all the time. If the display is 8, 8, 8, 8, it will be the maximum power consumption, which will be the combination of lowest power consumption 1, not 0, 0, 0, 0. 1, 1, 1 will be the combination of value which will consume least power, not 0, 0. Anyway, so all digits are always showing value. So obviously the power consumption will be higher. This is one thing. So we'll write the problems with static. Power consumption more, power consumption is more. Second problem is that if all displays are to be shown some values on, then all must be connected to the microcontroller explicitly. What does it mean? It means every display will be connected to microcontroller through separate IO lines. How many IO lines are required for connecting one digit to a microcontroller? We call it as a 7 segment display. So 7 lines are anyway required, right? Plus decimal point. So 8 lines are required for one digit. If all digits are simultaneously to be shown, so 8 into 4, 8 lines for one digit, 32 lines are required. So your microcontroller should be able to have those many, should have those many lines, and those many lines will be engaged all the time. right. So, number of IO lines required are more, number of input output lines, IO lines, IO pins required are more. So, if your processor is bigger enough, having more IO lines, then you can go for this. But typically everybody wants power consumption to be less. The circuit can be complicated, the software can be complicated because it has to be done once, but the power consumption is always going on, and that is why the power consumption should be reduced. So, we do not go for the first kind of display. So, static display is discouraged. Everybody understanding this? Right. Multiplex display should be used. Now, what is multiplex display? Multiplex display means only one digit is having some value at a time. Showing value at a time. For example, if the value is 1, 2, 3, 5, this is the value displayed, then it will be showing 1 in the first step and nothing here. Then afterwards it will be showing 2, then 3, then 5, and then again 1 and 2, 3, 5. So, this is the time axis. How much should be this time is unknown, we will decide this. We will decide how much time it should be. Right. Now, would you like to see this display? First thing is that the display does not show all values at once, only one digit is showing its value at a time. So, the power consumption will be limited to maximum 8 segments, only 8 segments will be there. How many digits are there? They can be any digits. Even if the digits are 10 digits, still at a time only 8 LEDs will be glowing. Everybody understanding this? So, the power consumption will be limited, power consumption will be small. So, what is the advantage of this? Power consumption is less. But the problem is that it shows only one value at a time, and we have to manage the timing. How to manage this timing we will understand. We can do that through software, and how to write software for that we are going to understand. Fine. Now, when we understand that it is a multiplex display and it shows only one digit at a time, would you like to see the display as 1, 2, 3, 4 once in 1 second? Number 1 seen for 1 second, number 2 seen for 1 more second. So, that will be not appropriate. So, we would like to see all digits at once. So, the rate at which this is shown must be fast enough, so that because of the persistence of vision we will feel that all digits are shown simultaneously. So, it will create an illusion of all 4 digits being shown simultaneously, but internally it will be showing the digits sequentially. Everybody understanding this? So, what do we understand about persistence of vision? We have some understanding. What is that? 1 by 16. What is that 1 by 16? Our human eye cannot bifurcate if the image is changing very fast. Maybe typically 25 pictures per second in television, 25 pictures per second, maybe 20 pictures per second, that you have to decide. So, here how many digits per second, that we have to decide. Instead of pictures, how many digits per second. So, if we have 1 digit 1 second, 1 digit 1 second, the display will be not appealing, display will not be proper, right. So, we can go for 20 digits per second. It means in 1 second 20 times the digits will be changed, 1, 2, 3, 4, 1, 2, 3, 4 and so on. So, this will be done so fast that in 1 second the instrument will show 20 such digits. It means the 4 digits will be shown 5 times. Getting the idea? right. So, if the persistence of vision tells us that there should be 20 changes in 1 second, so that we do not understand that there are changes happening, what should be the value of t? What should be the value of t? Can you so what is the requirement? The digits should be 20 digits. 20 digits should be shown in 1 second. So, how much time is for 4 digits?